Good evening everyone, myself Gautam Sharma. I welcome you all in Sapiens Education. So today I am going to discuss about the part 4 video, and here we will discuss about some of the conditions for the wave optics. So first of all, conditions of the bright fringe or a constructive interference. So let us, before that, we need to understand that what is intensity of the fringes. So intensity can be defined as 4 into amplitude square into cos square phi by 2. Okay. Now, I intensity will be, see, we are talking about the bright fringe, that is constructive. So if we want bright, so the amplitude should be maximum, and for this the condition should be that when cos pi by 2 is equal to plus minus 1, then only we will get that intensity as I is equal to maximum. Then I will be equal to I naught, that is equal to 4a square, that is the maximum. It means that pi by 2 is equal to n pi by 2 is equal to n into pi, or pi is equal to 2n pi is the condition. If we see the diagram of this, so what we can consider that this is, let us consider this is the wave like this, and this is a 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, like this. And we have another wave like this. Got it? Now when we observe this thing, so we have seen that the path difference will be lambda. Path difference will be how much? Lambda. So let us consider path difference. Yes. Hmm? Submit. So let us consider the wavelength of this is lambda. So the path difference will be lambda, and phase difference. So for lambda, so lambda, for distance traveled to be lambda, so the phase difference should be 2 pi. So if we write like this, that path difference divided by lambda, so the phase difference is equal to 2 pi. So for path difference to be lambda, phase difference to be 2 pi. So from here, path difference path difference can also be written as x. So x can be written like lambda by 2 pi, into phase difference, and for this phase difference we have phase difference is equal to 2n pi. So we 2 got cancelled, pi got cancelled, so the path difference become n into lambda. So this is the condition for the path difference, where n is equal to 0, 1, 2, 3, like this. Okay, so from here we can say that hence bright fringe is obtained when path difference of the interference of wave is n lambda. Okay, and phase difference should be should be 2n pi. Okay. Now let us talk about the similar condition, that is condition for the dark fringe. So dark fringe means what? When we construct the wave, so wave should be first will be like this, and another wave should start from like this, so that net we will get as a dark fringe. Okay, we will get as a dark fringe. So in dark fringe intensity will be 0. So when intensity will be 0, so we know that I is equal to 4a square cos square 4a square cos square phase difference by 2. Now I is equal to 0. So when I will be 0, when this value will become 0. So when this value will become 0, so let us see here, cos pi by 2 is equal to 0, and this will be then only I intensity will be 0, and this is the condition for the dark fringe or destructive interference. So from here we can say that pi by 2 is equal to 2n minus 1 2n minus 1 into pi by 2. Okay, so from here pi will be equal to 2n minus 1 into pi, where n is equal to 1 2 3 dot 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 dot. Okay, now if you talk about the path difference again, so the path difference will be how much? So path difference is, that is x is equal to lambda by 2 pi into pi. So put the values, so this will be 2n minus 1 into lambda by 2. Hence dark fringe are obtained with interference of the wave when path difference is all odd multiple of lambda by 2, and phase difference is all multiple of, and phase difference is odd multiple of pi. So I hope we have discussed about the condition for the dark fringe. Now let us discuss about expression for the fringe in interference. So we have seen that S1 and S2 are the source of light. Separated by a distance of d. Separated by a distance of small d. So this is the separation. So this we can see that these the two slits are there, and their slit distance is small d, and this is the screen. So distance capital D is the distance of the screen from the source of the light, and this distance is the distance from the central fringe to the next fringe, that is considered as x. and this is an angle theta, and by with the help of this we can find this angle as a theta, right? With the help of geometrical concept, so we can use this. Now if we consider, see here, if we consider a point P, consider a point P on the screen at a distance of x x from center, x from central fringe, that is O, that is O. Okay. Now the path difference. So path difference basically what? Path difference means distance travelable by this path to the distance traveled by this path. So path difference. So the path difference. Now here we will talk about the path difference. So path difference basically, path difference is equal to, path difference is equal to this distance, that is S1P and S2P. So that is equal to S2P minus S1P, and this will be equal to S2N, S2N. So we are talking about this one. So this is the path of this source and this is the path of this source. So the difference in this path difference is this one. So that is equal to S2N and S2N, and this is an angle theta. If you use the trigonometric concept, so S21 can be rewritten as d sine theta, d sine theta, because this is the right angle triangle. When we talk about this one, so if you observe this as a right angle triangle, so let us consider this as a right angle triangle. So that is S1 and S2 and N. So from here, right angle triangle, we have got d sine theta. So path difference is equal to d sine theta. Path difference PD is equal to d sine theta. Okay. Now since, let us consider this angle theta. Theta is very small. Theta is very small. Very small. So we can consider sine theta is equal to tan theta. So from here, path difference can be written as d tan theta. Now if you talk about the tan theta, so how you will obtain the expression for the tan theta? So this, if we talk about this one, see here, if we talk about this one, tan theta, if you want to find a tan theta, so let us consider, we have already considered this as a x and this as a capital D. So tan theta is equal to, tan theta is equal to perpendicular by base, that is equal to x by capital D. So from here, tan theta is equal to, we can write here d into perpendicular, that is equal to x by capital D. So from here we can obtain the expression for the path difference. So the path difference is equal to dx by capital D. So I hope you have understood this. Okay. So we have done some expression. So we will discuss about some of the constructive interference expression. So from here, for constructive interference, for constructive interference constructive interference, we know that the path difference is equal to n lambda. We have already done this condition for the constructive interference, where n is equal to, 1 2 3, like dot dot dot, even 0 also, right? Also path difference we have also derived now from here, that path difference is equal to dx by capital D. So from here, dx by capital D is equal to n into lambda. Okay. Now from here, x can be obtained as n lambda d by small d. Okay. What is basically x? So it is the distance of the nth fringe from the central fringe. So this is central fringe, this is your bright fringe. So this distance may be x. Let us consider this is next branch bright fringe. So this is your first bright fringe. So this is second bright fringe. So second bright fringe will be this distance. So if you want the distance, so let us consider distance for nth bright fringe is equal to n lambda capital D by small d. Okay, okay. And if we know want to find the fringe width of the dark fringe. See, distance between two bright fringe is the dark width of the dark fringe. So one important point you need to understand that the distance between two bright fringe is equal to width of the dark fringe. So it means that width of the dark fringe or fringe width of the dark fringe can be obtained by fringe width of dark fringe is equal to, see here, if this is your x2 and this is your x1, so fringe width will be what? Fringe width will be x2 minus x1. So from here we can infer that xn plus 1 minus xn is the fringe width. So from here we can put here n plus 1 d lambda by small d minus n lambda d by small d. So when we calculate this, so fringe width beta is equal to d lambda by small d. We have got this relation. So this is the fringe width of the dark fringe. Now let us go for the destructive interference. So let us consider about the destructive interference. So for destructive interference, for destructive interference, we know that the path difference in terms of lambda is equal to 2n minus 1 2n minus 1 into lambda by 2, where n is equal to 1 2 0 1 2 2, like this. And also path difference is equal to, we have already done that the path difference is equal to dx by capital D, and this is equal to 2n minus 1 into lambda by 2. Now from here we want x, the distance from the central fringe to the nth fringe. So from here x can be written as 2n minus 1 into lambda d by 2d. Now again, so we are talking about the dark fringe. So this is central fringe. So this is your dark fringe 1, dark fringe 2, dark fringe 3. And if you want to find the distance between two dark fringe, so this will be the width of the bright fringe. So from here we can say that width of the width of bright fringe is equal to distance between two dark fringe. So this will be equal to xn plus 1 minus xn. So xn is equal to this, we have already done. So can we write here fringe width beta is equal to 2 into n minus 1, sorry, n plus 1 minus 1 into lambda d by 2d minus 2n minus 1 into lambda d by 2d. So when we solve this, so what we will get? We will get as d lambda by t. So what we have observed that the fringe width of after observation, fringe width of dark as well as bright is same, and that is d lambda by small d. So I hope you have understood. So in next class I will more discuss about the some important points. So thank you for watching video.